Because there are at least 3 problems on every test dealing with either circumference or 4 problems, I'm sorry, out of 54 that deal with circumference or area. However, some of them look a lot trickier than others. Example. This is a circle circumscribed in a square. The side of the square is 12 centimeters. Find the area of the shaded region. This is so easy, it's not even funny. Imagine, just tell me in words, how would I take a figure, a piece of paper, and cut out this part? What would I do? Put it into words for me, Ryan.
Wouldn't you find the area of the square and then subtract it, like minus the area of the square?
That's all there is to it.
And since it's a square, 12 times 12 would be the area of the square.
So 12 times 12, 144 is the area of the square. 6 squared is 36. 36 pi is the area of the circle. Does anyone not see why it's 36 pi? Radius is 6, right? 6 squared is 36. Answer, that's all there is. Next question. That will be an answer on the SAT. By the way, 144, that shouldn't be 3.6, sorry. One of the possible answers will be 144 minus 144 pi. One of the possible answers will be 144 minus 12 pi. Do you see what they're doing in the distractors? They're giving you all the common mistakes that you could make.
Will they have like 12 minus 6 pi or something like that?
What's that? Yeah, they might have 12 minus 6 pi. Do you know what I mean? Or 48 minus 36 pi. Where did I get 48 from? The perimeter, right? And then the circumference of the circle would be 12 pi. Yeah, 48 minus 12 pi is a really common distractor answer there. All right. That, easy now that you see how to do it?
So what is 144 minus? That's just what
That's
it is.
the answer. It is what it is. If you want to multiply it by 3.14 and find out the decimal, you'll get an approximation. It sounds like a balloon burst or someone dropped something plastic. That's the answer. Okay, I know it didn't though. Trust me, gun would have been way louder. All right. With that in mind, picture this, if you will.
Oh boy.
That's easier.
Oh yeah, that's really not that.
Ain't nobody that has it. At all.
Find the area of the shaded region. In words, what is it? And these are all tangent.
It's 12 times 24.
It's the area of the rectangle minus
The air.
The circle area.
8 times the area of any one circle, right?
Yeah.
Well, the area of the rectangle is 12 times 24, which is 288. That's 12 times 12 is 144 times 2. It's 288 minus. Now the question is,
9 times 8.
what's the diameter of each circle? 6. What's the radius of each circle? 3. What's the area of each circle?
9 pi.
9 pi. Radius squared times pi. So this is minus 8, 9 pi's. 288 minus 70, 9 times 8 is 72. 72 pi is the answer. That simple. Okay?
I don't understand the 9 pi. Like, I don't.
Look at this length. How long is this from here to here?
12.
All right. Each circle has to be 6 long then, right? And 6 is the what of this circle? Look at it from here to here. See how it's the diameter? It goes from one end of the circle to the other, passes through the center. If the diameter, so you say here, all right, the diameter is 6, the radius is 3, and the area is radius squared times pi. Right? Right? Area equals pi r squared. What's r squared? What's 3 squared? 9 times pi. And how many circles are there that are identical in size to that? Okay. Feeling good? Awesome. Okay. Now, then there's this bad boy. Find the area of this part of a circle. This is so easy, it's not even funny. What fraction of the circle do I have here? How do you know that? It's 120 out of 360 degrees for the circle, right? Yeah. The radius squared is 36. Pi is the area of the whole circle. You take a third of 36 pi, 12 pi is the answer. Next question. Does that make sense to everybody? You know, okay with it? You okay with it, Karen?
The radius of the circle, of the whole, so the area of the whole circle.
Times the fraction of the circle you have.
Okay, so that would be 2 times 2 pi r, no, it's pi r squared, so that's pi, so it's 36 pi, and 1/3, so that would be 12 pi. Okay.
See it? Okay. Now. Last problem I want to show you. 2 last problems.
Wait, I have a picture here.
That's probably still 3.
That's our 5-minute bell. All right. What's the area of the shaded region? These are 2 concentric circles. So you're saying area of the big minus area of the little. What's the area of the big circle?
100 pi.
100 pi. Everybody see it? Radius squared minus 49 pi. Area 51 pi. Next problem.
Don't erase that yet.
I won't.
Wait, so we're trying to find the area of the whole thing?
I'm trying to find the area of this shaded region.
Oh no.
Okay,
Don't freak out.
36.
So this is called an annulus of a circle, A-N-N-U-L-U-S, otherwise known as a ring. All right? Find the area of that, which is area of the big minus area of the little, and you want 1/3 of that, don't you? It's 120 over 36. So this is 36 pi minus 16 pi is 20 pi. It's 1/3 of 20 pi, 20 pi over 3. Next answer. You see it? Why is it 1/3 of the whole thing?
The third.
120 over 360 is a third. This is chapter 7 in your geometry book.
Yay.
Done in 30 minutes.
The entire chapter 7?
Yeah.
Chapter 1, is that? Oh, that's next chapter.
Pretty much.
That's like a
That's
whole
next
book.
chapter.
Or it's 2/3 of the chapter. There's part that we haven't dealt with that you'll learn about tangent segments and secant segments and that sort
It
of
was
thing.
a waste of time to do all of this. Wait, so I have a question.
Yeah.
So find the radius of the area of the small circle and the big circle. Would it?
Guys, listen up. I got a question.
That would be pi times r squared. Oh, I get it. 'Cause
Get
it's
it?
Pi. Okay.
Pi, 6
No, I
squared
was
times
looking at that
pi.
one, but-
Yep, 4 squared times pi. Yep.
Got it.
Now, there is a time and a season and a purpose for you to write, especially writing plans out. I will never solve one of these problems until I write in words. The area of the big minus the area of the little, and that's the whole circle. I want 1/3 of the circle. I get the plan in my head before I start. And then I will write down the equation. Like if I was going to do this to be safe, I would figure out the plan, write the plan down in words like I did, or symbols, then write out everything, and then finish up the math in my head and double check it. If you did what I just showed you here, you would lose 3/4 of your points on a real geometry test because they will want to hear every step and how you solved every single step. But remember, my job here is not to teach you how to write out every single step. That's what your geometry teacher is for. My job is to get you to solve these quickly, because the faster you can solve problems accurately and correctly, the more time you will have to deal with the ugly problems, right, on the SAT. So I have a different purpose here than your homeschool teacher does. We have the same purpose in that I want you to understand the concepts. What I recognize is that you guys understand the concepts faster than kids. And guys, do not underestimate your homeschool teachers. They know how smart you are. They know you understand this faster. And I have to tell you that most of the homeschool teachers, because I meet with either geometry or calculus teachers, because there's no, there is no gifted math in-service. Like, on the in-service days when we go for training, I have to pick what subject I go to. I'll either go to geometry or calculus, depending on what I'm teaching in a given semester. If I'm doing trig, I go to geometry. If I'm doing an exploring calculus, I'll go to that. And their biggest frustration as homeschool teachers is they know you are bored to tears, and they're struggling with what to do with you during those periods where you get it in 5 minutes and nobody else gets it. So and here's one of the cool things. When I go to these meetings, they look at me and they're like, what do you do with the gifted kids on this stuff? And I show them. And it really is. Over time, hopefully you'll see it get better. I will miss you all terribly, terribly. And
We'll miss you.
Miss Wargul is the teacher name, Worgul. And I will be in touch with her at least 2 or 3 times a week during the duration. So, what's that?